So here we have last lesson 8-6 for mixed sequence problems. So again, everything that we're going through in this lesson is not new. It's all stuff that we've covered before in different examples and different lessons. Just this is kind of putting it all together again. So arithmetic, hopefully the first thing that's coming to your mind when you think of arithmetic sequences are linear relationships. And if it's linear, that means that it has that adding or subtracting by the same amount. And what that adding or subtracting by the same amount is, that's your common difference. AKA, another name for that common difference is that slope, or your constant rate of change. That's what a constant rate of change means, to be adding or subtracting by the same amount each time. With that arithmetic sequences, remember you are given the following formula. You are given a sub n is equal to a1 plus n minus 1 times d. That's the formula just as it is given on your reference sheet. Remember, that formula is just a different variation of your linear y equals mx plus b. Remember, we're just not using y and x anymore. We're using a and n, and our d replaced our common difference. That's our slope. So this is the same exact equation as a sub n is equal to y equals slope x plus my y-intercept, which remember that y-intercept is that a sub 0. So let's actually make a note of that. Remember that a sub 0, or a of 0, is my y-intercept. And last but not least, we're just going to jot down the recursive rule then. So that's what you're given, and I'll do the recursive rule right here. C-U-R-S-I-V-E, your recursive rule. Remember, every single recursive rule starts off the same with that a sub n is equal to a sub n minus 1. Here we're talking about arithmetic, so there's a common difference, meaning that we're just going to be adding that d to whatever the common difference is. And don't forget, with your recursive sequences, you need to give me that first or that starting term, whatever a sub 1 or a sub 0 is equal to. So that is our arithmetic. Clearly, I did not pay attention to all the room that I had. Okay, we'll move that there for now. All right, up next on the other side, we have our geometric sequences, which are very, very similar, and they are basically exponential relationships. They just don't have those decimal values, right? They're only the whole numbers. So if it's exponential, that means that it has what is called a multiplying factor. Right, we're multiplying or dividing by the same amount each time, which is your common ratio. And we're using that r to represent our common ratio this time. Your given formula, because you are given one of these on your reference sheet, the given formula for a geometric or an exponential is that a sub n is equal to a1 times r to the n minus 1. And remember, that is just the same variation. That's just a different equation, a different variables, different letters and stuff for that y equals a times b raised to the x power, which is also the same as my a sub n is equal to my y-intercept, that initial value, times my multiplying factor raised to the n. Same exact formulas. And last but not least, your recursive rule for this one. Scooch that up a little bit. So your RR, your recursive rule. Again, they all start out with a sub n is equal to a sub n minus 1. This one, since it has the common ratio, is times r. And then again, writing down what that first term is.